This lesson is on the sine rule and it's used for non-right angle triangles. Here's the rule in a box for you to have a look at. If you want to look at a formal proof of the rule, you can look at it on page 205 of the textbook and get excited about that. The sine rule is for non-right angle triangles. In the triangle that we can see here, if I'm trying to find the unknown side x, I can't use sine, cosine, or tan ratios. Why not? Because this angle here is not a right angle. Calculated this angle, it'd be 85 degrees, so there's no right angle triangle, no right angle in that triangle. So if I look at my decision rule, when I'm up here, does the triangle contain a right angle? If I could answer yes, I could use all this stuff I already know. Sine, cosine, tan, Pythagoras. However, I'm over here in the no section where I'm going to need to use something different. When I was using sine, cosine, and tan, I would have my triangle and the angle that I'm interested in, and I'd label the sides opposite, hypotenuse, and adjacent with a right angle here. When there's no right angle, we need to use a different naming convention. So we'll just call the three sides A, B, and C. So I'll label the three sides A, B, and C. And the angles are capital A, capital B, and capital C, where the angle is opposite the side. Okay, always opposite the side. So I'll keep that naming convention in mind and have a look at this problem, this unknown problem. You'll notice that sine rule, A on sine A, B on sine B, C on sine C, looks like it has two equal signs, looks really weird. We're probably never going to use all three at once. We might just use these two, or we might just use this equation, okay, or we might use just the A's and the C's. So let's have a look at trying to find this unknown side using sine rule. Some of you might be saying, oh, but I can cut this triangle in half, put a right angle here. I can use sine to find this side, okay, using this information, and then I can use Pythagoras to find x. Yep, you're right, but it's going to take you a long time. Sine rule will be more effective. Okay, first I need to label my diagram. I recommend that you always make the unknown side or the unknown angle C. It'll help out for the cosine rule as well. So I'll make this side C. So this is angle C, and I can choose any letter for the other ones. So A and B, however we go. So this would be side A, and this would be side B. So I've labeled the sides. Now I'm going to list what I know or what I'm trying to find out. So I know that angle C is 45 degrees. I know I'm trying to find what side C is. It's an unknown. I know that side B is 16 centimeters, and I know that angle B is 50 degrees. Hopefully you can see there that I've highlighted all that information I've written down, so I've collected all that info. And then I'll have a look at here. Oh, I've got informations about C's and B's. So I'm going to be using sine rule, and not the sine ratio, the sine rule, and I'm just going to choose this little section of it, the B's and C's. So I'll write my sine rule. Write my rule, then substitute in the values that I know or I'm trying to find. I know that B is 16. I got sine of 50 degrees equals my unknown x on sine 45. Okay, so same process as always. Write the rule, substitute in values, and then solve. To get x by itself, we need to multiply by sine 45. So this guy here multiplied by sine 45 degrees. I ended up with 14.77 centimeters. Just for those students that are interested, you can write this also as 16 sine 45 on sine 50. okay, by recognizing that there's a denominator of 1 there and multiplying top by top and bottom by bottom. Okay, that's how sine rule works for finding unknown sides. We can also use sine rule to find unknown angles, like in this example here. I look at the triangle, I can't see any right angle identified, so that means I can't use sine, cosine or tan ratios. I'm going to need to use the sine rule. As in the previous example, I need to label my diagram. I'll make my unknown angle C, and then I can label the other sides however I want. Okay, angle A is 61, angle B, not sure what it is, and I can put the sides corresponding. So again, I'll list what I know or what I'm trying to find. I'm trying to find angle C. I know side C is 123. I know side A is 116, and angle A is 61 degrees. So I'll look up to my sine rule, and I know I've got things to do with A and C. So this is the case where I ignore that thing in the middle, and I'm using that form of the sine rule. A on sine A equals C on sine C. The tip is that whenever you're trying to find an angle, that will flip both of these fractions over. So since I'm trying to find an angle, I want the angle on top. So I'm going to flip these two fractions over. Is that allowed to do? Well, let's just think of an example. If I know that a half equals 3 on 6, what happens if I flip these over? 2 on 1 equals 6 on 3. Well, does it? 2 equals 2, it looks good. Okay, I'm allowed to flip fractions if they're equal. From here, substitute in the values. So I know my angle is 61 degrees on 116. I'm trying to find theta, and side C is 123. I need to just get theta by itself. So I'll multiply both sides by 123. Then I'm trying to find that angle. Even though this is a big mess, I know to get rid of the sine, I need to find sine inverse of the other side. Okay, don't be scared, your calculator will be able to handle it. And we'll be able to type all this directly into our calculator and find that angle. Okay, that's what it looks like. Hopefully calculator's in degrees. Okay, it looks good, 68.03 degrees. Okay, so from here, now that you've practiced the skill of finding unknown side and unknown angle, I want you to have a go at these problems. So there's some finding the unknown side, there's some finding the unknown angle with the solutions there, and then go on to these maps questions in the textbook, which require the use of sine rule.